Okay, in this particular question, I decided, unlike the other projectile questions, to provide some numbers because with this last type of projectile question, it can get kind of messy if we're just working with variables. And I find it easier just to with the numbers in this case. So just to go over the question again, what we have is we have some kind of environment where there's a hill or some kind of target on top that is 8 meters above. So this here is 8. And then our projectile starts here and is going 50 degrees from the horizontal. So we're interested in this position right here. How far away is that from where we started the projectile in the horizontal? So that's the range that we're looking for. So we just wanted to hit the hill. This is essentially right at the edge. So let's start by breaking up our problem. Oh yeah, we should also probably put the velocity here. It's going at 18 meters per second. So let's write down our givens. And again, just like every 2D problem, we'll treat it as two separate problems, one in the x direction and one in the y. So let's start with our x-axis. We know the initial velocity, or the x component of the initial velocity, is equal to the magnitude of the vector multiplied by the cos of 50 degrees, and that's meters per second to the right. The acceleration in the x direction, like all projectiles, is 0. And we're looking for delta dx. And the key to this problem will be to solve for the delta t, but not in this axis first because we don't have enough information to solve for it. So we'll go, because we don't have enough information to solve this right now, we'll go to the y-axis. So with the y-axis, we know that the initial velocity in the y direction is equal to 18 sine 50 meters per second up. And that's this vector right here. So this vector plus this vector make 18 meters per second. The acceleration in the y direction is the acceleration due to gravity. And like always, we have to make sure that our directions are the same in order to manipulate them with a relationship. The delta dy in this case is 8 meters up, and delta t is unknown. But this delta t is the same as this delta t. So we can use a kinematic equation to try to solve for this delta t. So let's do that over here. So in the y-axis, and the equation that has all of these elements in it is delta dy is equal to viy delta t plus a half a delta t squared. And then we'll do our substitution. So this becomes 8 equals, and I should say that when you actually calculate this out, 18 sine 50, that ends up being 13.79 t. And then half of negative 9.8 is negative 4.9, and that's t squared. And then this is a quadratic, so we are required to use the quadratic formula to solve for t. So I'm going to rearrange this so that it's equal to 0. And then I assign this will be my A value, this will be my B value, and that will be my C value, where t is equal to negative b plus or minus b squared minus 4ac over 2a. So when I substitute all of these in, I get negative negative, which is a positive, square root of 13.79 squared minus 4 times 4.9 times c, which is 8, over, oops, over, what's going on here? Over 2 times a is 9.8. 9.8. So when you work this out, you end up getting two answers. You get 2 seconds or 0.82 seconds. Now the reason why you get two positive answers is because if you look at this, there's actually 2 points on this parabola here that are 8 meters above this ground. The first one is actually here, or abouts, and then the second one is here. Now the question says that we want the point where the object or the projectile is coming on the way down. So that's the greater of the 2 times. So we're going to be using this time here. So we're almost done. Next thing we have to do is just look at our x-axis information. So in the x-axis, we have delta dx is equal to vix times delta t. Well, vix is equal to, when you crunch this out, like 18 cos 50, that ends up being 11.57. So this number is that number. And then we multiply that by 2 seconds. And so we end up getting 23.1 meters to the right. So our final answer is the projectile is launched 23.1 meters away.